afternoon. Welcome to the class. Today we'll start with a new numerical on Mohr circle. So we have a two-dimensional body here, which is subjected to compressive stresses. Like you can see here, in X direction we have 90 megapascal, which is compressive in nature. In Y direction we have 60 megapascal, which is compressive in nature. And we have a plane, for example, plane XY, which is inclined at an angle 30 degree. And here we have, it is subjected to a shear stress of 60 megapascal. So in this problem, we need to determine the principal stresses, sigma 1 and sigma 2. Then we need to determine their location in the sense orientation. So those are nothing but the theta P1. Theta P1 is principal planes, location of principal planes, theta P1 and P2. Then we need to determine maximum shear stress, tau max, and its location of shear stress, that is nothing but theta S1 and theta S2. Then I need to calculate what is the normal stress which is acting on the given plane. The plane which is inclined at an angle 60 degree. On this plane, what may be the normal stress and what may be the shear stress which is acting on this plane. So those are nothing but the stresses which are acting on this plane which is inclined at an angle theta. So this is our normal stress. This is our sigma shear stress. So I need to determine the normal stress on this plane which is inclined at angle theta, and I need to determine this tau theta. Tau theta in that sense the shear stress on this plane. So if you calculate with the help of analytical method, we'll get these answers. So you can note it down these values. The sigma 1, the major principal stress will get minus 13.15 megapascal. If you calculate analytically by using this formula, I think you people know this. Sigma 1 is equal to sigma x plus sigma y divided by 2 plus root of sigma x minus sigma y by 2 whole square plus tau xy square. So from this formula, you can calculate the principal stresses. I hope so you people know this. So we'll go directly with the answer. So sigma 1 is the minus 13.15 megapascal, that is major principal stress, and minor principal stress sigma 2, the value of minor principal stress is minus 136.85 megapascal. And location of these principal stresses, those are nothing but theta P1, or you can write 2 theta P1 is equal to the angle, the location of major principal stress will get at 75.9 degree. And to calculate theta, then theta P1 will be 37 degree, 37.9 degree, approximately 37.59 degree. So then theta P2 will be 37.9 plus 90. So then it will be around 127.9. So these are the location of principal stresses, 37.9 degree and 127 point. Next we have like tau max. Tau max is major principal, maximum shear stress. Maximum shear stress is nothing but radius of Mohr circle. With the value for this will be around 61.85 megapascal. And its location theta S1 is equal to so theta P1 plus 45 degree. So theta P1 is nothing but this one. Next theta S2 is nothing but again theta P1 plus 135 degree. So this is about the location of maximum shear stress and maximum shear stress. These are the values which we get if you calculate analytical. Apart from this, apart from this, we need to calculate the normal stress which is acting on a plane which is inclined at an angle 30 degrees. So for this again we have this formula sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. So by using this formula, we need to calculate sigma n. If you substitute the values, you will get the sigma n is equal to minus 15.54 Newton per mm square or megapascal. Similarly, we need to calculate tau theta, or you can say the shear stress acting on a plane which is inclined at an angle 30 degrees. So if you use this formula minus sigma x minus sigma y by 2 sin 2 theta plus tau cos 2 theta, you will get around minus 17 megapascal. These are the values. If you calculate analytically, you will get these values. Now in this class, what we do, we go with the graphical method of construction of Mohr circle. To construct the Mohr circle, first we need to have the vertical and horizontal components. First we'll write what are the vertical and horizontal components. Then we can easily draw the Mohr circle. So what are those coordinates? First, to make a table like this. In this table, we can have the values. We can have the values. See, here we have stress. This is shear stress, vertical plane, horizontal plane. So this is our vertical plane. This is our horizontal plane. So on vertical plane, we have the stress which is acting in, which is compressive in nature. So minus 90 megapascal. And the shear stress which is acting on this vertical plane. On this plane, we have the shear stress which is acting in which direction? Clockwise direction. Clockwise in the sense, again it is minus. The sign conversion. Clockwise is negative and anti-clockwise is positive. Here we have horizontal plane. On horizontal plane, we have a stress of 60 megapascal, which is compressive in nature. So it is negative 60, and you can see here we have a shear stress which is acting in clockwise, which is acting in anti-clockwise direction. So anti-clockwise in the sense positive in nature. So first we need to have these coordinates, sigma coordinates and tau coordinates. If you know these coordinates, then we can draw the Mohr circle easily. So to draw the Mohr circle, first you need to have these coordinates, x coordinate and y coordinate. In x coordinate, you can see this is plus sigma, this is minus sigma, this is minus tau, this is plus tau. This is our reference point O. So let us assume some scale for this. Let scale is 10 megapascal is equal to 1 centimeter. Then here if you see, it is in sigma axis, it is minus 90 megapascal. 90 megapascal in the sense I need to draw 9 centimeter. Here it is negative. So here it is from O to here, it is 9 centimeter. Then we have this is in tau axis, we have minus 90 here. It is, sorry, it should be minus 60, I think. It should be minus 60 because here it is 60, right? It should be minus 60. So here we will get minus 60. Minus 60 in the sense this is minus So from here minus 60 somewhere here we get, this is our vertical plane. Similarly, we need to draw horizontal plane. To draw the horizontal plane here, minus 60 in sigma axis, minus 60 in sigma axis. So sigma, this is minus 60 somewhere 6 centimeter from here, and we have uh, plus 60 in tau axis, plus 60. So tau is plus is downward. So here somewhere here we get, this is 6 centimeter. This is our 6 centimeter again. From here to here, it is 6 centimeter. So this is my horizontal plane. Now we need to join this line. After this, we need to intersect this line, bisect this line, and draw the circle. Bisect that line and draw the circle. This will be the Mohr. This will be the Mohr circle. This Mohr circle. First, after drawing the Mohr circle, first what we need to do, we need to determine these values. First value, sigma 1, sigma 2, theta p1, or you can write 2 theta p1. These values will get easy. So from O to this point, so this is nothing but sigma 1. So O2 at this point, this is nothing but sigma 2. This is sigma 2. Major principal stress, minor principal stress. If you measure this, you will get the answer. Then this will be the 2 theta p1. This will be the 2 theta p1. And if you measure the radius of this, you will get a tau max. Tau max is nothing but radius of Mohr circle. If you measure the radius and multiply with this scale, you will get the answer. Clear? These are the values we get once we draw this. Sigma 1, sigma 2, tau max, and 2 theta p. Once we get this, the next step, next and most important step is we need to determine what are the stresses on a plane which is inclined at an angle 30 degree. So if you go to this two-dimensional diagram here, so whatever the angle which is present here, 30 degree, which is with respect to horizontal plane, but we need to take with respect to vertical plane. So with respect to vertical plane, this plane XY is making at an angle 60 degree. So total is 90 degree. So 90 minus 30 is 60 degree, which is making in, it is making in clockwise direction. So theta is clockwise. Clockwise in the sense, again it is negative 60 degree. Now we got theta is negative 60 degree. While we are drawing the Mohr circle, we should consider 2 theta. 2 theta in the sense minus 120 degree we need to consider. For this, we need to keep the protector on this. Like I'll show you how to keep the protector. This will be the center. You need to keep the protector like this. We keep the protector like this. If you measure from the angle is, which is angle is clockwise direction. So we need to take clockwise from here. From here we need to consider 120 degree. Somewhere here we get. So this will be the 120 degree. 120 degree. This will be the 120 degree. So once we get this 120 degree angle, then what we need to do, we should draw, we need to draw a line perpendicular to this. Perpendicular to this. Now we need to measure this value. So sorry, we need to extend this till this. From here we need to draw a perpendicular line. So this will be the sigma n. So you do one thing, I'll repeat this step, you'll understand. So you'll get, this is the 2 theta value. Till this is the 2 theta value. So this is nothing but 120 degree, that is, which is acting in clockwise direction. So now we got this point. From here we need to draw a vertical line. perpendicular to this axis. So this value is sigma n, and this value from here to here, this value is tau theta. And from O to this point, if you draw a line, this will be your resultant R. The resultant will be this line. This will be the resultant line. So you measure the values and multiply with the scale, you will get the answer. So let me know in the comment whether you are getting the right answers or wrong answers. So thank you for watching the video. If you need further videos, let me comment in the comment box. Let's see. If possible, I'll make some more videos on this. Thank you for watching.